welcome into this fantastic session of uniform circular motions, and we are in session 4 or period 4. And I would like to invite you also in our YouTube channel called the Tanzania Online A-Level Secondary Schools, Olenjolai M in square bracket. So my name is Olenjolai. I will be teaching you advanced physics, and we have begun this one topic of mechanics called uniform circular motion, and then we have to continue where we ended in period 4 or in period 3 or session 3 or lecture 3. In case that you want to offer your Thanksgiving, don't hesitate yourself to use this number, to use that number in order to send you a Thanksgiving by using the mobile transactions. Again, in case you have any questions, you can ask in the comment section down below there. Okay, so let us go to the session. So if you do remember that in lecture 2, this is quick review of what we covered, right? So quick review of lecture 2. Lecture 2 is short, and also lecture 2 and lecture 3. So in this lecture, I've been teaching about parameters. Okay, parameters used in circular motion or uniform circular motion. We learned many parameters. I think that almost, I don't remember exactly whether they are around 9 to 10, right? Something like that. So we learned many parameters. We learned the formulas. The first parameter we learned about angular displacement. I told you also about angular velocity. I told you about angular acceleration. I taught you another parameter called the periods. I taught you another parameter called the frequency. I taught you another parameter that we called centripetal acceleration. Then I taught you another parameter called the tangential acceleration. Then I taught you another parameter called the centripetal force, and another one we call the centrifugal force. Or you can just have this one. And hence, I think that how many are they? Almost there are 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So when I've been teaching you, I've been defining them. We have been defining them and also deduce some of the formulas, right? So I have been giving you some of mathematical formulas and even some of the demonstration. So today, I would like us to take the concept, or I will be solving questions or problems regarding these parameters. So I'll be so quickly or so fastly, in case that you find that maybe it means that I'm solving quickly or fastly, then you can pause the video and then you can review it several times as well as you can. So the title of this lecture is called the problem solving, right? So problem solving on circular motion. So I have the first example, and this is example 1. Okay. So in example 1, a race car, the race car, I used to watch them online. A race car negotiates what? Negotiates a curve of radius. Race car negotiates a curve of radius 50 meters on a flat road. And then the questions ask you what its angular displacement, right? What's angular displacement? What its angular displacement when its linear distance, covered by the car, is 18.5 meter. So let us read the question carefully and then solve it. Then we'll go to other examples. A race car, negotiate, this is G, negotiates a curve, a circular curve, of a radius 50 centimeter, like this one, on a flat road. What its angular? So the question is asking, what its angular displacement when its linear distance covered is what? 18.5 meter. What does it mean? Solution. We just follow 2 steps on these questions, then we solve it. If just you can either analyze the data, or maybe you can list it there, or you can have the data analysis. Okay? The data analysis, you can have the data analysis. The data was data given, just the data given, or you can present the information on the sketch. So the best way I choose, the first is say sketch the curve, right? So sketch the curve. So you say the curve, the question didn't say that the cycle. So you say it's a curve. You might find that possibly, because the question is general, so maybe this is the corner, or maybe yes, kind of the corner, right? From point A to point B. And then you find that the radius of that curve is 50 meter. Right? 50 meter. So because it's 50 meter, then what happens? So we say that it's linear, when it's linear distance, or the linear distance, linear distance means that if we take this one, because this is the car was negotiating this curve. Okay, so the car can draw its tires as she's navigating this curve in this way. And COT, so it has to result tangential velocity. This is tangential velocity. So if, for example, it means that we take point A and point B and then straighten it. When we straighten it, its length is equal to 18.5 meter at the minimum. So the question now asks you, what is angular displacement? So the question asking about what? Angular displacement. So this question asks us about the first terminology. Angular displacement, which is theta, is what this is required. Okay, so the second step, we say that recall the expression that you have. Angular displacement is equal to R. We say, I told you that the linear displacement, if you do remember, let me remind you, linear displacement, this is S, we call it, is equal to radius of the cycle, or radius of the curve times angular displacement. So simply, if you say that S is equal to R times theta, if you are looking for theta, we divide by R on both sides. So theta is equal to S over R. So what is S? S is linear displacement, which is what? Or linear distance, 18.5 meter, divided by radius. What the radius? Radius is 50 meter. So this and this will cancel. So use your scientific calculator to compute that division. So if you use your calculator, effectively, this is 78. I was wondering how comes that the angular displacement, or the displacement means that the length of this curve AB is less than the radius. So that's what I was wondering about. But I made a mistake on copying. This is 78.5. So theta is equal to 17.5 over 50. Hopefully it will be 1 point something. So the answer is 1.54. So if you use your scientific calculator, the answer is 1.54. Now I come to you, if you do remember that I told you how many units can be used to notate the angular displacement. 2. You have 2 units, either radians or degrees. So for this case, because meter and meter is cancelled, means the unit is radians, not degrees. right? So then, in case that you want the angular, so that's the one form of the angular displacement, right? But also can express angular displacement in what? Possibly in degrees. Sometimes in the questions you might be conditioned that express the angular displacement in terms of 40 of degrees. So it means that if you want to express theta in degrees, then what do you say? I told you that even if I want to make a minor corrections, possibly I remember that I made a mistake. Pi radian is equal to 180 degrees. Pi radians is not equal to 360 degrees. Okay? And then therefore you have 1.54 radians. So then this is equal to how many degrees? So you cross and then you find the value of 40 of angular displacement. So it will be at 180 degrees multiplied by pi radian and then divided by what? 1.5 for radian. If you do your computations, you'll find the angle is almost or approximately equal to 90. So therefore, we say that the answer of this question, we say that the angular displacement of the racing car, we can call it the racing car. Of the racing car. Racing car is what? Is 125 for radians, or this is equal to 90 degrees. So that the response. So then we can go to another example. That will be example 40, example 2. So you may see how questions are being asked, a little bit tricky, but I believe that even yourself, you are careful enough on solving them, because this is how advanced level used to be. So example 2. Number 2. Let's see the way it is asking. It has two parts, part A and part B. Part A say that, can a body move? Can a body move on a curve? On a curve. Body move on a curve without having acceleration. Can a body move on a curve without having acceleration? Then you have part B. Right? Part B states that a stone tied to the end of the string. To the end of a string. The end of a string. The end of the string. 2 meters long. Is really okay, really in a horizontal cycle. Remember that these questions might be asked in midterm exam, in the final exam, in the mock exam, with constant speed, if the stone makes 10 revolution, make 10 revolution, make 10 revolution, make 10 revolution in 10 seconds. Calculate the magnitude. Calculate the magnitude and direction. Calculate the magnitude and direction of acceleration. Acceleration. That's the question. Let's read the question. The first question, can a body move on a curve without having acceleration? If the answer is yes, explain why. How will it move without acceleration? And then, if the answer is no, explain also why. Why it can't move in a circular motion, so not in a curve without acceleration? That is part A. Part B, a stone tied to the end of the string, 2 meters. So this is T. This is T, excuse me. This is T. And this is R, and this is I. So string, 2 meters long, is really in horizontal cycle. With what? With constant speed. If the stone makes 10 revolutions in 20 seconds, calculate the magnitude and direction of acceleration. Solution. With Roman A, what are you saying? Take a minute and think, or take a few seconds to think that. Is it possible for a body to move in a curve without acceleration? No. Why no? Because I told you have to refer. Why no? First of all, what is acceleration? Is the rate of change of 40 speed, or is the rate of change of 40 velocity? In terms of circular, or what acceleration are we talking about? Angular acceleration, right? How does it change? Does it change or does it remain constant along the curve? How does it change? How does it change? So the issue here you have to understand the scenario or the concepts of 40 of circular motion. So for you to have a right answer for that case, it means that before even you say yes or no, you have to sketch the cycle. For you have to draw the cycle because you have drawing tools. So if you sketch the cycle, so this is the center, and this is the center, and this is the radius. Let's say from here to here. So this is your region. Right? So if that's the case, we say that suppose a body is at this point, what will happen? Does it possess acceleration? This is point A, let's say. Does it possess acceleration? This is point B. Does it possess acceleration at this point or not? That's the question at hand. So remember that I taught you about tangential velocity and I taught about tangential acceleration. So for this case, if the body is moving in clockwise direction, then this is what happens. So this is velocity and this is velocity. If you do remember that I told you an acceleration that we call the tangential acceleration. So what the aims of tangential acceleration? Should you remember? Or what the aim of centripetal acceleration? The aim of accelerations, or the aim for a body moving in uniform circular motion to have acceleration, is in order to change or to maintain the directions of the body moving circular paths to be in circular. Because if there is no anything else or any acceleration that maintaining these circular motions, when the body reaches at this point, then it can flip in a straight line. So then we say that it's not possible. So the answer that yeah, say that no. Why? Because so say why? Because because when a body is moving, in a curve, the velocity of the body, most of the body, which is tangential velocity, changes with time. Because it changes with time, then acceleration change. And the body moves in circular paths, is always in accelerated state. So because when a body is moving in a curve, the velocity of the body changes with time, and the body is always in accelerated state. That is A. So let us go to part B. B, a stone tied to the end of the string. Suppose that is the string, right? And then we tie a stone at this end, and then we cause it to move in a horizontal circular curve. So this is what we call the horizontal circular curve. So vertical is in case that the string and the stone is rotating or revolving in this form, right? So similarly for this case, we say that the stone tied to the end of the meter is really in a horizontal circle. It's a constant speed. If the stone makes 10 revolutions in 20 seconds, calculate magnitude and direction of acceleration that maintaining a string and a stone, or expression that is a stone to describe what is a circular path. So for this question, the first state, we say that you can say sketch the problem, or sketch the horizontal circle. So to sketch the horizontal circle, suppose that is the point where your hand is, and then we say that this is the process, and then here this is the process. So this is the horizontal circle. Then we say that suppose this is the center. So here we have radius, we have all center, then stone tied to the end of the string, which is 2 meters long. It's really like that one at that point. So the length of the string is 2 meters. So it means that the length of this string is 2 meters. So remember that it's still the same string at this point. So suppose that this is point A, this is point B, this is point C, and this is point O. Right? So that's what we call the horizontal cycle. Okay, so its length, the length of the string is that one. And then the stone makes 10 revolutions in 20 seconds. So mean that the stone has its frequency, which is 10 revolutions. It makes 10 revolutions in 20 seconds. So it means frequency is equal to 0.5 per second, or what? Or hertz. Or revolution per second. So it completes 10 revolutions in 20 seconds. So one revolution, so you mean that this body, it can complete 2 revolutions in 1 second. That's the meaning. Because complete 1 revolutions in 0.5 seconds. So the question asks us to find the acceleration that will maintain that stone. Because remember that the stone will be possibly at this end, and this will be the one that is describing the circular path in this way. So this is what we call the stone. We have possibly even a lecture of studying horizontal cycles, if you remember in the table, in the contents that I gave you. That's the first state. The second state, now, we need the acceleration. What accelerations will be moving? Which type of acceleration that will cause this stone to move in a horizontal cycle? Angular. The acceleration that will make this the stone to move in circular path is called the centripetal acceleration. So you say that you call the formula, and I taught you 3 formulas of centripetal acceleration. Of what is centripetal acceleration. Okay, so the centripetal acceleration, we say that is given as square of the linear velocity over radius of the cycle R. And then we start thinking, what the data to be given? Do we know the value of 40? Do you know the value for linear velocity? No, we don't know. So if we don't know, what should we do? What should we do? It means that we should think about it as a formulas of centripetal acceleration. These formulas, we say that we can express this in terms of angular velocity. So we know linear velocity is equal to angular velocity times what radius r. If you square this one over r. So centripetal acceleration is equal to omega square r square over r. So the answer is omega square r. But again, I told you, angular velocity is equal to twice pi, or is equal to theta over time. So it is twice pi of what? Over t. So it is twice pi over t, which is time is it's a period, so over t. So because you have 2 pi over t, then we are going to have 1 over t, that's called the reciprocal. Say reciprocal. Reciprocal of period is equal to frequency. So this is the first equation. So remember that centripetal acceleration that we're looking for is equal to angular velocity r is the first question. And then we come that we say that angular velocity is equal to 2 pi over period t. And this is equal to 2 pi and 1 over t. This is equal to 2 pi and frequency. So this is equation 2. We go for the steady state. Substitute question 2 into question 1. So we say centripetal acceleration is equal to what? Is equal to 2 pi times frequency square with the radius r. So then this is equal to what? Is equal to 4 pi square then frequency square r. So to find the centripetal acceleration that will keep a storm in the horizontal cycle is equal to 4, then pi is 22, or you can use this pi in the scientific calculator, square, and then frequency, we form that is 0.5, that is square. Radius of the cycle will be is equal to the length of the string. So remember that radius of the cycle is equal to the length of the string, so which is equal to 2 meters. So you say that centripetal acceleration is equal to what? Use your scientific calculator. So if you use your scientific calculator, well, I think I should wait to look for that. That means centripetal acceleration. So I think you have got it. So it is 19.74 meters per second. Per second square. 19.742 meters per second square. What is the directions of centripetal? Where is the direction of centripetal acceleration? So therefore we say the centripetal acceleration that is required is 19.742 meters per second. And they always, you say that only, always, it is, this centripetal acceleration is directed towards the center. Towards the center. So we have determined the required acceleration to maintain that body or that stone in circular path. At the same time, also, we found its directions, which is toward the center of the horizontal circle. So let me teach you example 3. And this example 3 has 2 parts, A and B. During uniform circular motion, during uniform circular motion, name the quantity name the quantities which remain constant. Name the quantities which remain constant. Then here we are at B, a motor car traveling artery, traveling artery, 30 meters per second on a circular road. On a circular road of radius 500 meters. It is increasing its speeds at the rate of 2 meters per second square. And the question is, what is its acceleration? Physics is beautiful, and advanced physics is the best friend of a student. Okay, the question said that during uniform circular motion, not non-uniform, name the quantities which remain constant. Pause the video and then think and name yourself. Because sometimes that you can get kind of laziness. You are just waiting for me to write there and then you call. That's not a good way of learning. Good way of learning, you should involve your understanding, your intelligence on what you are learning effectively. How? You should ask yourself questions, and even sometimes you should think beyond what has been taught. So, tell me in the comment sections, at least before I mention, which physical quantity in uniform circular motion do you think that will remain constant along the process? Whether it is horizontal cycle or it is vertical cycle. And then if you manage to do that, we can go and solve example 3 at B. I think you have named or you have mentioned. So let me continue. So during a circular motion, then the quantities should remain constant. How do you know the quantities should remain constant? You should refer lecture 1, no, lecture 2, mostly lecture 2 and lecture 3. Lecture 2 and 3, main, even lecture 1, because we define that uniform circular motion, we say that the type of the motions whereby a body experiencing a circular motions are different at constant speed, okay, at constant speed at different directions. So we have even mentioned one of the physical quantity. So the first physical quantity which remain constant is what? Speed of the body, not velocity. Velocity will be changing. Speed of 40 of the body. And then the second quantity is kinetic energy, because the body will be kinetic energy. We expect that body will be moving in a circular path, right? Continuously, without changing without changing its mass and also without changing its speed. Because kinetic energy, we know that in this scenario is given as is equal to a half times mass times velocity square. So this is not velocity, this is speed. Okay? So for example, we say that because some of the examples of the uniform circular motions, I told that it's the movement of electrons around the nucleus of an atom. So it's always mean that electrons is moving the constant speed, because the speed is constant and even kinetic energy also is always constant. Another parameter which we didn't mention, these two other parameters we did insist them in lecture 1 and 2 and 3, but I'd like to insist them at this point. Another parameter which we mentioned, but we didn't learn whether it is changing or whatever, is called the angular velocity. Why angular velocity and not angular acceleration? Because remember, angular acceleration depends on the linear accelerations. You say because when the body moves in a circular path at every point, it's changing what directions. So because the directions is changing, so we say that accelerations and accelerations is also what a vector quantity. So another parameter is, we call it angular velocity. So those are the three parameters that we expect them to change or to remain constant along the circular motions. We expect them to remain constant. If you have any questions, don't hesitate yourself to ask in the comment section. So that's about your angular velocity. Okay. So you have again part B. So those are the quantities which remain constant when the body will move in a straight line. Again, we have part B. A motor car, say a motor car. It's like nearly to Swahili language. A motor car traveling at 30 meters per second on a circular road of radius 500 meters. It is increasing its speed at a rate of 2 meters per second square. What is its acceleration? So this is a little bit conceptual question because the questions has already gave you acceleration. And then it is asking you acceleration. It has to repeat the question. A motor car traveling at 30 meters per second on a circular road of radius 500 meters. It is increasing its speed at a rate of 42 meters per second square. What is its acceleration? That's the question. Check which acceleration is being asked. And why are you given radius, why are you given velocity? Why are you given that acceleration, incremental acceleration? So what acceleration is it being sought? Which acceleration? Because the motor car traveling at that was on a circular road. So it is circular, not linear. A circular road has a radius of 500 meters. It is increasing its speed at the rate of 2 meters per second square. What is acceleration? So we say the first state So if you analyze this info that will be given not velocity or speed, be given radius, be given another acceleration. It should be changing. So we'll be given speed of what? Motor car. And then this is equal to 30 meters per second. And then we'll be given sort radius. And then we have what acceleration. You got 2 meters per second square. And then what is required? Also acceleration. but this now will be called total or resultant acceleration. This is required. So you say that this body has a constant velocity of, it began with a constant velocity of what? Centimeter per second. And then the radius is 500 meters. And also the acceleration is 2 meters per second square. That's the increment of velocity. So what does it mean? It means that here we have two types of the speed. Should be careful. Then so the velocity or the speed exists, but it is increasing its speed at the rate of 2 meters per second square. We should ask ourselves which type of that acceleration. That is called the tangential acceleration. Is the only one which it can increase when the body is moving in circular motion. Tangential acceleration is the one that might change when the body is still in the motion. Centripetal acceleration, we might find that it doesn't change when the body is still in the motion. So for instance, that we say second state, this is for compression. So here we have radius of 500. And then we have velocity of the body that's moving. And then this body is moving. There's a tangential acceleration which is increasing now, which is 2 meters per second square. But again, when it is moving with that acceleration, there is another acceleration acting toward the center, which is centripetal acceleration. The speed of the body at this state, it is centimeter per second. Radius is 500 meters. So centripetal acceleration, so this acceleration is total acceleration. So you say centripetal A subscript of C acceleration is what it requires. Required it first. Required. And I told you that the formula, we have 3 formulas to find the centripetal acceleration. The first one, we say that the square of the linear velocity of radius r. Okay? So according to the question, all the data will be given, so centripetal acceleration. The velocity, the final velocity is 30 meters per second square. Meter per second, this is square. And then we say that over R is 500. So the answer is equal to 900 meter square, second square. So centripetal acceleration will be, you cancel d0 and d0, 9/5, which is 1.8 meter per second square. So this is centripetal acceleration. But the question didn't ask you the centripetal acceleration. It asked the total acceleration. So the question asks you, because the question asks you that, what is acceleration? So total acceleration. So you go for this is almost the steady state. We go to the force state. The force state. So the force state, we say that, okay, fine. You have to recall the formula of resultant or total acceleration. So this is a subscript of t. I told you in lecture 3. Okay? Is equal to centripetal acceleration. Centripetal acceleration square plus tangential plus the square. So centripetal, if you understand physics, it becomes simple. But if you don't understand, this might become the enemy of yours. So be careful. So we say that we have what centripetal acceleration, which is 1.8 meter per second square. Square plus centripetal acceleration, tangential acceleration, which is 2 square. So you get the total acceleration. Use your scientific calculator, get the response. What's the response there? So it is 227 meters per second square. Not centripetal, the total acceleration of the body, of the stone, not the body, because the name is actually of the stone, is what? is 2.7 meter per second square. Right? If you have any questions, don't hesitate yourself to ask in the comment section. That was example 3. I have also example 4. Write the magnitude calculate the magnitude of linear acceleration of a particle moving in a cycle of radius 0.5 meter at the instant when its angular velocity is 2 radii per second square and its angular acceleration is this is radii per second. When its angular acceleration is 6 radii per second. We can try before we solve. We allow the space is free for you. Calculate the magnitude of linear acceleration of the particle moving in a cycle of radius 0.5 meter at the instant when its angular velocity is 2.5 meter per radii per second and its angular acceleration is 6 radii per second. Take your time, think how you can solve it. Examine the acceleration that you'll be given. And all the parameters that you'll be given. And then we'll solve another questions which was in the past paper. You have option, you can sketch or cannot sketch. Calculate the magnitude of linear acceleration. Say linear acceleration. So linear accelerations, you know that means that they are linear acceleration. And then of the particle moving in a cycle of radius 0.5 meter at the instant when its angular velocity is 2 radii per second. And its angular acceleration is 6 radii. So maybe it's better if we do data analysis first, and then we see what will be given in terms of symbols. The first stage, what are we given? That are given, right? So we'll be given first the calculated magnitude of linear acceleration. So we need to find the linear acceleration. Linear acceleration is required to be found, which is R. This is required. And then we'll be given say, a particle moving at radius 0.5 meter. Radius, which is R, 0.5 meter. At instant when its angular velocity is radii per second. So the angular velocity which is omega is equal to 2 radians per second. radians per second. We have angular acceleration. Say angular acceleration. Angular acceleration, which is alpha. Angular acceleration, the radians are 60 radians per second. So what you require, linear acceleration of the particle. So if you do remember that, I told you that when a body moves in circular thrust, it experiences both of the acceleration. Or all the three acceleration, linear acceleration, both acceleration, linear acceleration, and angular acceleration. And in case of these angular accelerations for the circular motion, we have two types of angular acceleration. There's the angular acceleration. So just know that we have two types of angular acceleration. The first one is what? Tangential acceleration, and second is what? Centripetal acceleration. So always in circular, regardless of how the questions will be asked, if you read something about what? The linear accelerations, about circular, or about rotational sometimes, you find also you should know whether that physical quantity is constant or what. Okay? So I have all our filters. So the second step, let us compute angular. Let us compute tangential linear velocity. Tangential velocity. No, tangential acceleration. So let us compute tangential acceleration, which if you do remember that we had notations of A subscript of T. So we like to say that the tangential acceleration is always equal to linear acceleration, and the relationship between linear acceleration and the angular velocity and the angular acceleration, we say that the linear acceleration and this tangential acceleration, they are equal, right? So themselves, how do we find them? We find them by taking angular velocity to radius r. Okay? Angular velocity times radius r. Excuse me. This is for velocity. This is angular acceleration. Remember that linear velocity relate with angular velocity by using this expression. Linear displacement relate with angular displacement by using this expression. Linear acceleration relate with angular acceleration by using this expression. So you see, radius is common for them. Never forget that. So you say that tangential acceleration for this model is equal to radius. What the radius? Radius is equal to, or is equal to angular acceleration. What is angular acceleration? How we give angular acceleration? Yes, it's 6 radians per second square. Then what is r? Radius of the circuit is 0.5 meter. So then what do you say? So you find that tangential acceleration 6 times 0.5 is equal to 3. But this will be what meter times radius is meter square. That's tangential acceleration. Right? Then we go for the steady state. The steady state, we say that let us compute centripetal acceleration. Let's compute centripetal acceleration. Why should you compute centripetal acceleration? Remember that the question asked us to find what? Linear acceleration. So these linear accelerations correspond to the total acceleration of the body. Because a body moving in circular motions, it has both tangential acceleration and what? Centripetal acceleration. So centripetal acceleration we say that for this case is equal to linear velocity over radius r. Then we know velocity of the body or speed of the body. Do you have it? No, we don't have it. Do you have any speed? No any speed at the beginning of the question. So I told you how many form of the formulas of centripetal acceleration, the rate. So this is not suitable. So you have to go the other one. How do you get the other one? You just have to remember this. The other ones we get from the definitions of what? Linear velocity or final velocity is angular velocity times radius square of what? Of radius. And then this is equal to angular velocity times radius of r. Radius square of r. So then 1 r and 1 r comes. So centripetal acceleration is equal to angular velocity times radius r. Okay? So if that's the case, at least we have angular velocity, the big given from the question. At this point, particle moving in a cycle of radius 0.5 meter at the instant when its angular velocity is 2 radii per second, its angular acceleration is that one. So what the angular velocity? It is 2 radii per second. So if that's the case, we say that there we have 2 radii, but this should be squared times radius of the cycle, which is 0.5 meter. Then we can get our centripetal acceleration. So it will be 4 over that one is 2 meter per second squared. After having centripetal acceleration, the questions ask us what? Find what linear acceleration. So you have to find resultant or total acceleration of the body that moves along with the circular, uniform circular path. So then we say that this is step 4. The first step, we say that let us compute now the total So compute the total acceleration, total linear acceleration. Total linear acceleration. So I use this notation. So to compute the total linear acceleration, you have to recall the formula I told you. We do it in the triangle. We say that if you want to find it here, and then you have to follow the rules. And the rules is tangential acceleration square plus what? Tangential acceleration plus centripetal acceleration square. So the total acceleration is equal to the square. What is total tangential? What's the tangential velocity? Tangential velocity. Clean it. Fine. Forget it. Tangential velocity is equal to 3. Tangential acceleration, excuse me, not the velocity. Tangential acceleration is equal to 3 meters. 3 meters per second square. And then centripetal acceleration is equal to 2. So it's equal to 9 plus 4, 15. Right? 9 plus 4 is equal to 13. Now square root of 13 meters per second square. Or you can express in terms of what? You can use Centripetal to find this one. This ranges from what is almost a 4.3. Classifying the square root of 13 is what? In terms of decimals. 3.6. 3.6 what? Huh? One letter. Are you sure? Meter per second square. So you say that therefore total linear acceleration. Total linear acceleration of the body is 3.6 meter per second square. Okay, so that's how we solve questions of introductions of circular or uniform circular motion. And then now it's a good time for me to give you the homework that you can try at home when you cover this syllabus. It doesn't mean that those are the only question that you have to solve. There are many questions. You use a reference textbook to do many questions as well as we can, because that's how you become victorious in advanced level. So this is the example 5. And this question, we got it from Refer Advanced Certificate Secondary Certificate, Advanced Certificate Secondary Education Examination, Paper 1 of 2019, question 5. Just 3 Romans. So Roman 1 says, in which aspect does circular motion differ from linear motion? Which aspect does what? In which aspect you does circular motion differ from linear motion. So the question is, in which aspect does circular motion differ from linear motion? Why there must be a force acting on the particle. A force acting on a particle why there must be a force acting on a particle moving with uniform speed. This uniform speed. In a circular path. why there must be a force acting on a particle moving with uniform speed in a circular path. Why? Think. So the question number 1A, Roman 1 and 2 are just they need too much description and some few drawings just to support your ideas. Figure 1 below shows a particle moving below shows a particle moving in a semicircular. In a semicircular path AB. Of radius 6 meters. Of radius 6 meters. With constant speed. With constant speed. Constant speed of 12 meters per second. Calculate the average velocity. Calculate average velocity. This is the trajectory. So that the semicircular, because the question said that the figure 1 below shows a particle moving in semicircular path AB of radius 6 meters with constant speed of 12 meters per second. Calculate the average velocity. Then the last part for this question is B32. The stone type is the end of string 80 centimeters long is real in the horizontal is real in a horizontal cycle is constantly speed. It's constantly speed, making 25 revolutions. 5 revolutions. 5 revolutions in 14 seconds. 14 seconds. Determine the magnitude of its acceleration. So if you do the whole question, you get 10 marks. So I show you the format of NECTA questions or Advanced Certificate Secondary Education Examination questions. Okay, let us read in case that maybe writings is not clear. This is for Advanced Certificate Secondary Educations, paper 1. It is question number 5, 2019, in which, so question number 5, let's say, so this is question number 5, Roman A and Roman 1. In which aspect does circular motions differ from the linear motion? I mean, the questions ask you that in what aspect, so what the unique difference between circular motions and linear motions. Okay, so that the main questions. I mean, there's a certain aspect that I told you in lecture 1, 2, and 3 that you have to mention there. And then questions 8, Roman 2, we say that why there must be a force acting on a particle moving with uniform speed in circular paths. Why do you need a force? Why? I told you the reasons why in lecture 2. Lecture 2 and 3. Mainly lecture 3. Then, so you can go through those lectures before you answer these questions. Then the question number 5b, Roman 1, figure 1 below shows a particle moving in semicircular or in semicircular path AB of radius 6 meters with constant speed of 12 meters per second. Calculate the average velocity. Average velocity. Not the angular velocity, not linear velocity, not tangential velocity. Calculate average velocity. So the speed from A to B is 12 meters per second. And then the distance from here to O, A to O is 6 meters. And from O to B is 6 meters. Then another question, 5B, Roman 2. A stone tied to the end of the stream 8 centimeters long is reeled in a horizontal cycle with constant speed making 25 revolutions in 14 seconds. Determine the magnitude of its acceleration. Right? So if you can manage to solve these questions, I would like you to say it is the end of these sessions, and which is periods or sessions on lecture 4. Make sure that you go through, you repeat this video, you watch it several times as well as you can. Make sure also you do the homework before we meet in another session. And make sure also you try your level best to do even some other questions, because I try my level best to solve 5 questions. Doesn't mean that it's all, but there are many questions in the textbook that I've mentioned in the questions in the answers books. So go through them and then you'll find yourself that you're becoming competent in questions of uniform circular motion. So I'd like to thank God who have been with me in these sessions. And I'd like also to thank God for you who have been watching this video wherever you are. Tell us in the comment sections which continent are you come from, which country are you from, which city are you come from, which regions are you from, which school are you from, which district are you come from, and which ward are you come from, and which village and even the street that you have come from. Tell us in the comment section, please. Make sure also subscribe onto our channel that called Tanzania Online's A-Level Safety Schools. And also share these materials with your colleagues, because it's not the time for struggle. It's the time now to use the technology that we have in order to make stuff simple as well as possible. So I would like to say that may God bless you, and let's meet you in the next lecture. I will meet you inside of the next lecture.